Welcome everyone. Marine diesel engines have evolved dramatically with electronic common rail injection, delivering precise fuel control, lower emissions, and superior efficiency across all loads. Today, we spotlight one of the legends in this field, the MAN 48/60. This four-stroke powerhouse, with its 480mm bore and 600mm stroke, pushes up to 21,600 kilowatts in V18 configuration, combining rock-solid reliability, ultra-low fuel consumption, and top-tier environmental performance to drive cruise ships, tankers, and more. Let's dive in. Today I'm on board the ship, standing right here in front of this absolute giant, the MAN 48/60 diesel engine. Before we get into the details of its electronic common rail injection system, let's do a quick walk around to really appreciate how huge it is and how packed it is with sensors, pipes, and all the accessories that make this beast so reliable at sea. Now we're zooming in on one of the key stars of the common rail system, the high-pressure pump design used in the MAN 48/60. This is a robust, compact unit that builds the massive fuel pressure we need, up to around 1,500 to 1,800 bars, to feed the common rail accumulators. This pump is the real workhorse that enables the flexible, efficient, and clean injection the 48/60 is famous for. Let's dive deeper into the high-pressure pump. Look at this cutaway. The heart of it is the plunger, this long piston that moves up and down to compress the fuel to those extreme pressures. It slides inside the monoblock cylinder, a super strong, integrated block that houses everything tightly for reliability and minimal leaks. Fuel enters through the suction valve at the top, which opens to let low-pressure fuel in during the plunger's downward stroke. Then, when the plunger rises, it pushes the fuel out through the delivery valve, preventing backflow and sending high-pressure fuel toward the common rail. The valve carrier holds these valves in place, and the valve solenoid controls precise actuation for metering. Down at the bottom, the drive, connected to the engine's camshaft or gear, powers the whole reciprocating motion. This rugged design ensures consistent high pressure up to 1,800 bars, even on heavy fuel oil, making the whole injection system ultra-flexible and efficient. Incredible precision in such a tough marine environment. Here we see exactly how fuel moves through the CR 1.6 high-pressure pump in the MAN 48/60 crossing. Low-pressure fuel oil enters at 11 to 12 bars, shown by these yellow arrows, coming from the booster and supply system. It flows into the pump, gets compressed by the plunger inside the monoblock cylinder. Then, the high-pressure fuel, now up to 1,850 bars, is pushed out toward the common rail, following this red path here. The orange arrows show the return or leakage fuel at much lower pressure, going back to the system or for cooling. This precise flow path, with tight sealing and robust valves, allows the pump to deliver huge pressure reliably, even when running on heavy fuel oil, so the injectors can do their multi-shot magic for clean, efficient combustion. Beautiful engineering in motion. After the high-pressure pumps build up the fuel pressure, it all comes together in the common rail, the accumulator. It is the central storage hub. Here's a fantastic cross-section view of the common rail accumulator. This long horizontal pressure pipe in the center stores fuel at very high pressure, up to around 1,850 bars, supplied from the high-pressure pumps or the previous rail unit through those bottom connections. It's encased in a double-walled shell for maximum safety. Any leakage is contained and directed to break leakage points, preventing fuel spray in the engine room. At each injector takeoff, you see the valve group carrier with the valve group. These control the precise timing and duration of fuel delivery to the injection valve above. Right in the middle is the flow limiter, that purple piston unit we talked about earlier, which acts as an emergency shut-off if flow becomes too high. And on the ends, cut-off valves allow isolation of sections if needed. This modular, super secure design keeps rail pressure stable across all cylinders, ensures fast injector response, and builds in multiple layers of protection, essential for a big marine diesel like the 48/60 CR running thousands of hours at sea. The whole unit is normally closed for safety. It's controlled directly by the engine's injection module, which sends a short voltage pulse to the valve solenoid up here at the top. That's what opens and closes everything in milliseconds. Inside, we have two integrated solenoid valves sharing the same form factor, the 2/2 way valve and the 3/2 way valve. The exact same external design is used on both the 32/44 CR and 48/60 CR engines, though internal parts like orifices and springs are sized differently for each engine's flow and pressure needs. Here's how they work together. The 2/2 way valve acts as the pilot, It controls the 3/2-way valve. When the solenoid gets pulsed, the 2/2-way valve opens or closes to direct control pressure, which then switches the larger 3/2-way valve. This 3/2-way valve connects high-pressure rail fuel either to the injector's control chamber to close the needle or to drain to open the needle and start injection. This clever two-stage setup allows ultra-precise, multi-shot injections, pilot, main, post, all optimized for load, emissions, and fuel type. No mechanical cams, just pure electronic control for maximum flexibility and cleanliness. The whole unit is normally closed for safety. It's controlled directly by the engine's injection module, which sends a short voltage pulse to the valve solenoid up here at the top. That's what opens and closes everything in milliseconds. Inside, we have two integrated solenoid valves sharing the same form factor. Now let's pull back and see the full hydraulic layout of the common rail system on the MAN 48/60 CR. How pressure is generated and stored. At the bottom we have the low-pressure fuel supply coming in at 11 to 12 bars, shown in yellow. This feeds the high-pressure pumps, which you see here as these pumping units with their drive from the engine. The pumps deliver fuel at up to 1,850 bars maximum. That's the red high-pressure lines, straight into the accumulators, the long red horizontal sections that act as the common rail storage. These accumulators are connected in series so pressure is shared evenly across all cylinders. From each accumulator section, high-pressure fuel goes up to the valve groups, one per cylinder, which control the exact delivery to the injectors, shown as the injector symbols at the very top. There's also a separate low-pressure circuit in green at 5 to 7 bars for cooling, leakage return, and booster functions, with a minimum differential pressure of 5 bars maintained across the system. Everything is monitored and commanded by the SA zone control system on the right, using signals from the reference wheel for precise timing. This complete hydraulic circuit ensures stable high pressure, quick response,